Hi, and welcome to Allen High School's 10th grade pre-AP or honors chemistry. We're talking now about chemical and physical changes. Now, a change, remember we're going to be using that symbol delta. I want you to get used to that for change. Chemical versus physical changes. Now we're not talking about the potentiality, but we're talking about the actuality. Now, in a physical change, the identity of the solution is not altered. So if I took water, let's say ice, solid water, and I melted it, I have bonds here between hydrogens and oxygens, and those aren't being broken. It's bonds between water molecules that are broken. The H2O stays intact. Whoops, that should be liquid. Sorry, not aqueous. The H2O stays intact when we go from solid to liquid and then on to gas. So all of our phase changes are all physical changes. So we're going to be going through those phase changes in another video. We will refresh your memory of those. So phase changes are all part of these. So melting, boiling, freezing, condensing, and so forth. Other things that we do, grinding. Now, we've got dissolving down here, but dissolving is a little bit ambiguous because it can, in some instances, be considered a chemical change. And so I'm going to talk to my colleagues about maybe leaving that off the list for now, since AP especially is pushing that ambiguity of dissolving as in terms of whether that's a chemical reaction or a physical change. So grinding, churning, like when you're not feeling good and your stomach is churning, part of that churning is the physical property of just pushing the food around in your stomach. Tearing, ripping, like you could tear paper, ripping, tearing, ripping. A chemical change, chemical changes transform. We're going to have bonds being formed, bonds being broken. Formed and or broken. We have new substances with new properties because we've changed the structure. If you change the structure, you change the function. So if you break bonds and or form new bonds, then you have a new structure. If you have a new structure, you have a new function. Now, we have in the lab some key indicators. Let's call that evidence because we have to do an evidence section in our lab. And these provide evidence that a chemical change has occurred. An unexpected change in the temperature, the heat energy. So maybe the beaker got hotter, indicating that the system released heat to your hand, or it got colder. In other words, it's sucking heat from your hand, like chemical hot pads and chemical cold pads. That's evidence of a chemical change. A gas is produced. So if you observe bubbling, we interpret, and it's not boiling, right? So if you observe bubbling and it's very clear you're not heating the substance to the boiling point, then we know a gas is being produced. So the bubbling becomes evidence of the production of a gas. An unexpected change in color. We're going to add two liquids together and get two really clear and colorless liquids and get a beautiful yellow precipitate. Unfortunately, it's lead, so they used to put it in lead-based paints, which we don't do anymore. But color changes are evidence of a chemical change because the color is dependent on the structure. So if we've changed the color, we've somehow changed the structure. That means we've broken bonds or formed bonds. A solid precipitate. I'm just going to use PPT for precipitate. You want to learn some shorthand there. We're going to see some cloudiness that would typically settle. So it might be a suspension for a while, but then it would settle. Now, this next one really relates to number 2, an apparent mass change. A true mass change would only occur in a nuclear reaction. An apparent mass change means you've lost gas. It's escaped to the surroundings. It's no longer part of the sample that you're putting on the balance, and so you have an apparent mass change. Now, if we'd done the reaction or had the chemical change occur in a closed system, then we would be holding that gas in and you wouldn't see the mass change, okay? So if we see a new odor, or not see, but smell a new odor being produced, like if we produce H2S, it's going to smell like rotten eggs. If we make NH3, it's going to have a characteristic smell of ammonia, and I bet your mom has some ammonia. And again, man, somebody remind your old lady teacher here to, pull out some of this stuff from the back room and show you and let you get a better feel for this. If light is produced in way especially of a fire, we know that a chemical change has occurred. So those are our evidence of our chemical and physical changes. And we're going to be doing some demos, and you'll be doing a lab. And so you're going to be observing many of these chemical changes in action. So until then, this is, whoa, can't write today, YBCT, your best chemistry teacher, signing off. Love you guys.